In this video, we're going to be solving applications of problems that could turn into polynomial equations. And in particular, we're going to be talking about problems involving area of rectangular objects. So, this first problem on the left says the area of a rectangular garden is 105 square meters. The width is 2 meters longer than 1/3 of the length. Find the length of the width of the garden, or the length and the width of the garden. Alright, so what we do is we start with what we don't know. I know something about the width. The width is 2 meters longer than 1/3 of the length. What I don't know anything about is the length. So the length is going to be my variable. Actually, let me write this out. Length equals L. I do not know anything about the length. What I do know something about is the width. So instead of writing W, I'm going to write 2 meters longer than 1/3 of the length. So I'm going to start with 1/3 of the length, and I want 2 meters longer than that. Now that I've defined my variables, I can write an equation. I know that area of a rectangular object is length times width, and instead of writing length times width, I'm going to write what I think my length and width are, represented with these expressions. So the area was 105 square meters. I'm going to replace A with 105. I'm going to replace L with L. I'm going to replace W with 1/3 L plus 2. That whole thing is how I calculate my width. Whoops, plus 2. Then I'm going to go ahead and distribute. So I need to get rid of those parentheses first. So 1/3 L times L would be 1/3 L squared, and L times 2 would be 2L. Then I need to get rid of this fraction. I don't want to deal with that fraction. It makes it difficult for factoring. So I have to multiply both sides of my equation by the denominator, right? I don't want this 3 here, so I'm going to multiply both sides by 3 to clear out that fraction. So what do I have when I multiply 3 times 105? That is 315. And then 3 times 1/3 would be 1. So those 3's divide out, and I just have L squared. And 3 times 2L is 6L. And make sure every single term gets multiplied by 3 to keep that equal. Alright, now I have L squared and 6L on one side. I want to get all of this on the right-hand side to keep that L squared positive. So I would subtract 315 from both sides to have 0 equals L squared plus 6L minus 315. And from there, now that I have it set equal to 0, I can use that zero product property, meaning I need to factor. So I want factors of negative 315 that are going to add up to positive 6. So notice this ends in a 5, so 5 definitely goes in. I'm going to go ahead and try something a little bit bigger. How about 15? 315 divided by 15 would be 21. And one of them has to be negative to multiply to a negative, but I want it to add to a positive 6. So I'm going to put the negative with the smaller number so it adds to a positive number. Then, since that front coefficient is 1, I can go straight into my factors of L minus 15 and L plus 21. Once it's totally factored, then I can set each factor equal to 0. Whoops, L minus 15 equals 0, and L plus 21 equals 0. I'm going to add 15 to both sides, so L could be 15. subtract 21 from both sides. L could be negative 21. However, I can't have a negative length. It doesn't make sense to have negative 21 meters. That answer doesn't make any sense. So it must be 15 meters. And if I want to find the width, it's 1/3 the length. So 15 divided by 3, 1/3 the length, and then 2 more. So 15 divided by 3 is going to be 5 plus 2, or 7 meters. Let's write that up here. 7 meters. So that's how you do it. You plug in, you start with what you don't know. I didn't know anything about L. I write down what I do know about the width. I also know area is length times width. So I multiply these two together. It equals the area that I started with, or that I knew it would be. And then I solve. So I cleared out my fractions, everything on one side, factored, set each factor equal to 0. I knew I couldn't have a negative answer, so it had to be that positive answer, and then plugged in the 15 here to figure out the width. Go ahead and try the one on the right. Example on the right says the length of a rectangle is 3 inches shorter than triple the width. The rectangle has an area of 60 square inches. Find the length and the width of the rectangle. So the length of a rectangle is 3 inches shorter than triple the width. So I know something about the length. This time I don't know anything about the width. So my variable is going to be W. And then my length, I do know it's going to be triple the width and 3 inches shorter than that. So 3W minus 3. That shorter than tells you you're going to end up flipping the order of the way you read it to the way you write it. Alright, I've defined my variables. I know area of a rectangular object is length times width. And the area of our particular object is 60 square inches. So I replace A with 60, and I replace length with 3W minus 3 times my width. Again, I have to start by distributing these this W to get rid of those parentheses. So 60 equals 3W squared, and then minus 3W. Just distributing that in. I want to keep this highest degree, the W squared, positive. So I'm going to subtract that 60 over to both sides. So now it will be set equal to 0 equals 3W squared minus 3W minus 60. To make your lives easier, start with the GCF. So I want to factor. I'm going to start by pulling out the GCF. All three terms here have a 3 in common. Divide that out. I'm left with W squared minus W minus 20. Now I'm looking for factors of 20, of negative 20, that will add up to negative 1. So 4 and 5 are 1 apart from each other. One of them has to be negative to make this negative. And since I want my middle term, my B term, to be negative 1, I'm going to put negative with the bigger number. So negative 5. My front coefficient is 1, so I'm going to go directly into my factors of W minus 5 and W plus 4. I set each factor equal to 0. And sometimes I see students want to do something with that 3, and it's true, it is a factor, right? It's something being multiplied here, but can 3 ever equal 0? No, those can't ever be, so this 3 is not part of my solution here. I'm going to set the other factors with the variables equal to 0. Add 5 to both sides, so w equals 5. And then subtract 4 from both sides, so w could be a negative 4. But again, we're talking about distances here, about lengths and widths, so I can't have a negative solution. Darn it. I'm going to go ahead and throw that one out. I can't have a negative width length. So that means that this will be 5 inches for my width. And then for my length, I'm going to multiply that width by 3, or by 3, and then subtract 3. So 15 minus 3 is going to give me 12 inches. And there you go. And of course I can check this because I could multiply these together and they need to equal the 60 square inches for the area. Alright, there you go.